Okay, even and odd functions. When I'm talking about even and odd functions, I'm not talking about even and odd degree functions. They're different than even and odd functions. So an even function is a function that is symmetrical around the y-axis, which means that if you take your hands like this and pretend the y-axis is in the middle, it looks exactly the same on one side as it does the other. It's like a mirror image. Okay? So an even function is symmetric above the y-axis. If I draw or attempt to draw a picture of an even function, so if that's the right branch of the function, then the left branch of the function. Sorry, Kyle, you going to ask something?
About or above?
About.
Oh.
About the y column. So this is the right branch of it. So the left branch is a mirror image of it. Oh, best I can. So what that means, if you take a, say a value a, and you plug it into the function, you're going to get the function value evaluated at a. Bless you. If you take the negative of that value a, and you plug it in, because it's a mirror image, you're going to get the exact same answer. It's exactly the same on either side. So graphically, the way you determine whether something is an even function is if it looks exactly the same on one side, and if you flip it over, mirror image on the other side. Any questions on that? Okay. What I'm going to expect you to do is to be able to prove whether a function is even algebraically. And to prove whether it's algebraic, you have to use this property. An even function satisfies the property Okay, so here there's a whole bunch of math symbols, right? What this means is if I substitute negative x into the original function and then simplify, and when after I simplify I end up with the original function, okay, then it's an even function. This upside down looking a, does anybody know what that represents in math? It stands for the words for all, and x is an element in the domain of f. So this reads f evaluated at negative x is equal to f at x for all x that exists in the domain of f. Okay. If that's true algebraically, then you can say it's an even function. An odd function is a little bit different. So an odd function is rotationally symmetric around the origin, which means you have to picture it rotating where the point of rotation is right at the origin, and you're rotating 180 degrees. So the rotation is 180 degrees. So I'll draw a picture of that. X. So again, if I draw the right branch of the function, the origin is the point of symmetry. So if you can picture taking this and rotating it 180 degrees, and if you do that, you'll end up with that. So if that happens, then it's an odd function. And odd functions, if I take that a value and substitute it in, I'm going to get this answer here, which is some negative value. And if I take the negative of that a value, plug it in, I'm going to get the opposite. I'm going to get the positive of that value. So we can identify whether a function is odd if it has point symmetry at the origin. If it has point symmetry somewhere else, it's not an odd function. It has to be at the origin. Okay? And we can tell algebraically by using this property. An odd function satisfies the property. If I take negative x and substitute it into the original function, and then I simplify, and the answer works out to be the negative of the original function for all x that exists in the domain of f, then you can say that the function is odd. Okay. So I'm going to do two examples, actually three examples, using this property here, okay, and the even property. So determine if each function is even, odd, or neither. So you will 110%, this will be the last question on your test. It's going to ask you determine whether functions are even, odd, or neither. If you just write the word even and you're right, you'll get 1 mark. Okay? To get the other mark, you have to show me the algebraic proof. When you're determining whether it's even, odd, or neither, it's all done the exact same way. Okay? What you do is you write down f at negative x, just means substitute negative x into the function. So you'll do that. So everywhere you see an x, you're going to replace it with negative x. That's your first step. Your next step is to simplify. So negative x to the power of 4 becomes positive x to the power of 4. And negative x squared becomes positive x squared. And you can see after I've simplified, after I've plugged in my negative x and simplified, I end up with the original function. And since I end up with the original function, it's an even function. Okay? I can't stress this enough, and I'm guaranteeing I'm going to get people that are going to do this. I'm going to ask this question, they're going to write even, and they're going to argue with me that they want full marks. I will not give you full marks unless you prove it. Okay? Any questions on that? Okay, let's try another one. In doing these, especially if you're doing most of them, you'll be able to identify whether it's even or odd right off the bat, okay, by looking at the exponents. But again, I want to see the algebraic proof. Y and f of x are interchangeable, so if it's y, you can still write negative x, substitute it in, the negative. Simplify, negative x to the power of 5 is negative x to the power of 5, and now the bracket's gone. And that negative multiplies in front to give me negative 6x to the 5. Much the same fashion. Negative x to the power of 3 is negative x to the power of 3, but now that negative multiplies to the 3, and I get positive. So now it's time to look at it. That doesn't match the original function. Okay? So if it doesn't match the original function, it's not even. Now it's time to check to see if it's odd. To check that it's odd. No, you can grab some, I guess. Yeah. Okay. So to check to see if it's an odd function, factor out a negative. So if I factor out a negative, I'm left with that as the expression. If you've done it correctly, which I don't think I did, that should have been positive. Okay, so now I've done it correctly. look inside the bracket. If inside the bracket matches the original function, which it does, then you can say it's the negative of the original function, and now you can say the function is odd. Any questions so far? And I'll just do an example of when it doesn't work out. So if I have something like that, always start by substituting the negative x into the function, simplifying. It doesn't match the original function. If it doesn't match the original function, it's not even. Try factoring out a negative. After you factor out the negative, it still doesn't match anything, so then it's neither. Any questions on even and odd functions? Okay. So when I ask a question exactly like this, and I will on the test, determine whether a function is even or odd, I want you to show me the algebraic solution and then determine whether it's even or odd. Okay? So that's all you need in order to be successful on your test.